In this section 9.2, I'm going to be covering the exact same thing, which is solving systems of linear equations using matrices through Gaussian elimination with back substitution or Gauss Jordan elimination. The only difference in section 9.2 is that we are going to be looking at systems with no solutions and infinitely many solutions. Let's go ahead and begin with this problem. Use Gaussian elimination to find the complete solution of the following system of equations or show that none exists. So I'm going to be trying to do Gauss Jordan for all the problems. So I'm going to do the row operations as usually on the right side. I'm going to show you all of them here. And let's start with the augmented matrix in this problem. So the augmented matrix is going to be 9, 29, 1, 10 for the first row, 4, 13, 3, negative 6 for the second row, and 1, 3, negative 5 and 8 for the third row. Now remember that the first step in the process is that we need to make the first number a 1. Now the option that we had to make it into a 1 on the previous section was that we needed to divide everything by 9 or multiply by the reciprocal of 9, which is 1/9, to make it a 1. However, on this section we have something easier that we can do, and it is also one of the row operations that you have listed in the section 9.1, which is that since you see that there is a 1 down here on this row, this can only be applied to the first step. I can interchange these two rows so that I can bring this one to the top row. So that would be easier than me dividing everything by 9. So remember how you say that you're going to interchange? R1, double arrow, R3. So that's the first thing we're going to have here. So let's rewrite the matrix with the first row on the bottom and the third row at the top. And of course, the middle row stays the same. Now, next step in the process. After making the top number into a 1, second step is to make the two numbers below zeros. Okay. How do we make those two 4 and 9 zeros? Make it a 0 means we want to cancel them. And to cancel them, we need to use the process of addition. That's what I showed you on the previous section. So we need to add them to another equation, and that equation is going to be always, you're going to add them to the equation that you made into a 1. Okay. So if I want to make that for a 0, I need to add it to the first equation. So that's what we're going to do here. 1, 3, negative 5 and 8 is going to be added to 4, 13, 3, and negative 6. So if I want the 4 to cancel out with the 1, the first thing is that we need to multiply the 1 by the opposite of 4, which is negative 4. So that's the first thing. So then we multiply by negative 4, we're going to get negative 4, negative 12, 20, and negative 32. And then what we need to do is, we need to bring this other equation, 4, 13, 3, and negative 6, and we're going to add them together. So negative 4 plus 4 is going to be 0. That's what we wanted to get right here. Negative 12 plus 13 is a 1. That's a 1 there. 20 plus 3 is a 23. So we have a 23 on this position. And negative 32 plus negative 6 is negative 38. And we're going to bring down the first row. I forgot to bring it down. And what I want you to do, as usual, I want you to give me an equation in terms of rows for the operation that we use to change this middle row into this new middle row. So we multiply the top by negative 4, which is negative 4 times row 1, and then we added it to the second row. And that's how we got these numbers. Now we're going to do the exact same thing. Now we want to make this 9 into a 0. To make it a 0, we need to add it to the equation that we made into a 1, which is to the first equation also. So let's add the first equation to the third equation. So it's 1, 3, negative 5, and 8 is going to be added to 9, 29, 1, and 10. So if I want to make the 9 into a 0, in order to cancel out the 9 and the 1, first I need to multiply the 1 by the opposite, which is negative 9, and then we're going to add them. Negative 9 times 1 is negative 9. Then negative 9 times 3 is negative 27. Negative 9 times negative 5 is positive 45. And negative 9 times 8 is negative 72. And then what we need to do is, we need to bring this equation down, which is 9, 29, 1, and 10. And again, we are going to add these two equations. Negative 9 plus 9 is 0. Negative 27 plus 29 is 2. So we got 0, then 2. 45 plus 1 is 46. And then negative 72 plus 10 is negative 62. Now, we did the first step and the second step. The first step was to make the top number in a 1. The second step was to make these two numbers in the bottom zeros. Third step, we need to make the number in the middle a 1, but fortunately it is already a 1. So we're going to go directly to the fourth step, which is make that 2 below that 1 into a 0. So to make it into a 0, we need to always add it to the equation that we made it into a 1, which is to the middle equation. So we're going to do 0, 1, 23, and negative 38 is going to be added to 0, 2, 46, and 62. So to make that to a 0, first we need to multiply the 1 by the opposite of 2, which is negative 2. So negative 2 times 0 is 0, negative 2 times 1 is negative 2, negative 2 times 23 is negative 46, and negative 2 times negative 38 is 76. Then we need to add them to these values, 0, 2, 46, and 62. So when we add them, what's going to happen is we get a 0, 0, 0, and oh, I forgot right here, this was, let me see, negative 2. That was supposed to be a negative 62 right here. So I forgot right here, this was a negative 62. So then 76 plus negative 62 is going to be a 14. So that's what we get on the last row. Let's put it down on the last row, which is 0, 0, 0, and 14. And I'm just going to bring down everything else, which is 0, 1, 23, negative 38, and the top is a 1, 3, negative 5, and 8. So we already got the first 4 steps in the process. We made that a 1, we made the bottom one zeros, we made that a 1, we made the bottom one 0, and then the 5th step in the process, we need to turn that 0 into a 1. Now, before I do that, I keep forgetting to put this. I'm going to write the 2 operations that I did to change this 9 to a 0. We multiplied the top by negative 9, and then we added it to the bottom, which is to row 3. And then I'm also going to put how we just changed this one in the middle into a 0. We multiplied the middle one by negative 2, and then we added it to the third. Okay, so that's it. Now, the last step in the process is that we need to make that 0 into a 1. Now, to make it into a 1, the only operation that we use, remember, is that we need to divide everything by that, by something, or multiply it. By what can I multiply or divide this equation so that the 0 becomes a 1? It cannot be turned into a 1. So I'm going to put right here, it cannot be turned into a 1. What does that mean? Since it cannot be turned into a 1, this is one of the special cases that we covered back in section 8.1. When all of the variables, like when you get 0, 0, 0, that means that all of the variables, the x, the y, and the z, canceled out. And this was the deal. When all of the variables cancel out, that means that this system has either no solution or infinitely many solutions. All we have to check is if this equation is a true statement or a false statement. So if we rewrite this equation, this means 0 equals to 14, which in this case 0 is not equal to 14, so that's a false statement. So since this is false, that tells us that this system has no solution. Or you can say that this system is inconsistent. That's the same thing as saying no solution. So once we get 0, 0, 0 on the bottom, that automatically is going to tell you that the system has either no solution or infinitely many solutions. So if you get 0, 0, 0 and a number that is not 0 on the right side, then that's automatically a no solution. However, if you get 0, 0, 0 and 0, that will be a system with infinitely many solutions. So right here we got a no solution. So we don't have to continue once we find that it has no solution. Let's go ahead and answer the following question. The next thing is going to be, we're going to use Gaussian elimination to find the complete solution of this system or state that none exists. So we're going to set it up the exact same way. We're going to first write the augmented matrix for this, which is going to be 3 right here, then 12, then negative 13, and then the equal sign, then negative 1. Then we have a 2, a 9, negative 10, and then the equal sign, negative 3, and 1, 3, negative 3, and positive 2. So what we need to do next is this. First, we need to make the top number into a 1. Now, how do we make that 3 into a 1? We can either multiply by the reciprocal of 3, which is 1/3, or divide by 3. That is one of the options we have. However, that's not the simplest one. You see that just like on the previous question, we have a 1 on the bottom row. So interchanging rows will be the easiest way to make that a 1. So I'm going to switch row 1 and row 3. That will be the best thing to do. So let's go ahead and do the switch here. So that is going to give us the following: 1 here, 3, negative 3 and 2 for the top, and then 3, 12, negative 13 and negative 1 for the bottom. And the middle one stays the same: 2, 9, negative 10, and negative 3. So after making this top number a 1, step number 2 is that we need to make the 2 and the 3 zeros. Okay, this is when we're going to use the row operations here. So to turn those two into zeros, we're going to always do one at a time. Okay, we're going to start with the middle. So in the first row, I'm just going to bring it down automatically. So to make the 2 into a 0, we need to add it to the equation that we made into a 1, which is to the top equation. So we're going to add the 1, 3, negative 3, and 2 to the second equation, which is 2, 9, negative 10, and negative 3. So in order for this to become a 0, then first we need to multiply the 1 by the opposite of 2, which is negative 2. And then we're going to add them. So if I multiply it then by negative 2, that gives me a negative 2. Negative 2 times 3 is negative 6. Negative 2 times negative 3 is a positive 9. And negative 2 times 2 is a negative 4. Then we need to add them to these values, which is 2, 9, negative 10, and negative 3. So when we add them, negative 2 plus 2 is going to be a 0, so that's what we get here. Negative 6 plus 9 is a 3, so that's what we get here. 9 plus negative 10 is negative. Oh, I made a mistake here. Hold on. Negative 2 times negative 3 is positive 6, not a 9. So let me correct this. Positive 6. So then 6 plus negative 10, it's going to be negative 4. And negative 4 plus negative 3 is negative 7. Okay? So I want you to write what is the operation that we used to make that negative 2 to change these values here into these new values. So we multiply the first equation by negative 2, so negative 2 times row 1, and then we added it to the second equation, which is row 2. Now, the next thing, now we need to make the 3 a 0. To make the 3 into a 0, we need to also add it to the equation that we turn into a 1, which is to the first equation. It's going to be 1, 3, negative 3 and 2 needs to be added to the third equation, which is 3, 12, negative 13, and negative 1. So first I need to multiply, to make it into a 0, multiply the 1 by the opposite of 3, which is negative 3. So I multiply the negative 3 to all of these values. So that gives me negative 3, negative 9, positive 9, and negative 6. And then we're going to add them to these values. To 3, 12, negative 13, and negative 1. So when I add them, negative 3 plus 3 is a 0 for the first value. Negative 9 plus 12 is a 3 for the second value. 9 plus negative 13 is negative 4 for the third value. And negative 6 plus negative 1 is negative 7 for the last value. And that gives us the first two steps of the process. So the first step was to make the top number as a 1. The second step was to make the bottom one zeros. Now, step number 3. Well, before I go into that, give me the operation that we used to make that, to change these values into these values. Right here. We multiply the top equation by a negative 3. Negative 3 times row 1. And then we added it to row 3. Now, so we did steps 1 and 2, which is the 1 and the zeros. Step 3. Now we need to make the middle one into a 1. How do we make it into a 1? By multiplying this row by the reciprocal of 3, which is 1/3, or multiply by 1/3 is the same thing as dividing by 3. So just divided by 3. So I'm going to take the whole row, 0, 3, negative 4, and negative 7. And you can say either multiply it by 1/3 or divide it by 3. So I'm just going to divide it by 3, which is the same thing. 0 divided by 3 is 0. 3 divided by 3 is 1. Negative 4 divided by 3 is negative 4/3. And negative 7 divided by 3 is negative 7/3. So that's what we are going to get in the middle row. So the middle row is going to be changed to 0, 1, negative 4/3, and negative 7/3. And then I'm just going to bring down the other two rows. 0, 3, negative 4, negative 7, and 1, 3, negative 3, and positive 2. So far we got the first 3 steps in the process. We make the 1 at the top, we make the zeros at the bottom, we make the 1 in the middle. Step number 4, we need to make that 3 in the bottom a 0. Now, to make it into a 0, we always need to add it to the equation that we made into a 1, which is to the middle equation. So we're going to take the second row, which is this, and we're going to add it to the third row, which is 0, 3, negative 4, and negative 7. So, first thing before we perform the addition is this, that we need to multiply. In order to make the 3 a 0, we need to multiply the 1 by the opposite of 3, which is negative 3. So that gives me a 0, negative 3. Negative 3 times negative 4 is 12. Divided by 3 is going to be a 4. Then the last one is negative 3 times negative 7 is 21. Divided by 3 is a 7. And then we're going to add it to 0, 3, negative 4, and negative 7. And what happens when we add them? Everything here is going to become a 0. So the bottom row becomes 0, 0, 0, and 0. I'm just going to bring the other two rows. 0, 1, negative 4/3, negative 7/3, and the top, which is 1, 3, negative 3, and positive 2. So, what is the operation that I used to change these numbers into these numbers? I multiply the second row by negative 3, and then I added it to the third row. Last but not least, now I want you to look at what happened. We got 0, 0, 0, 0, meaning that what I told you before is that once you get a 0 on this position, you can't make it back into a 1. So that basically means when you get 0 equals to 0, this is a true statement, and this tells you that this system has infinitely many solutions. Infinite solutions. Okay. Now, anytime we have infinite solutions, we still have to write the solution as a triple. However, the solution is we need to write an equation for x, for y, and for z that will generate all the solutions of the system, that will generate all my infinite solutions. That's what we need to do next. Okay. So, what I do recommend is that we continue doing it all the way until we do the Gauss Jordan elimination. I'm going to continue all the way. Okay? But now in this problem, since the last row is 0, 0, 0, 0, that means that one you can just ignore it. That one no longer exists. So all we need to focus on right now is on these two. Okay? So if we focus on these two, you see that we already got the 1 here. We already got the 0 here. We already got the 1 here. So there's only one more thing missing, and that is to make that 3 above into a 0 as well. It has to be 1, 1, and then zeros on the bottom and 0 at the top. Okay? So we only need to make that 3 into a 0. So if I want to make that 3 into a 0, once again, we need to add it to the equation that we made into a 1, which is to the second equation. So we're going to do 1, 3, negative 3 and 2 is going to be added to 0, 1, negative 4/3, and negative 7/3. But the first thing that we need to do in order for this 3 to become a 0 is that we need to multiply the 1 by the opposite of 3, which is negative 3. So negative 3 times 0 is 0, negative 3 times 1 is negative 3, negative 3 times negative 4 is 12, divided by 3 is going to give us a 4. Negative 3 times negative 7 is 21, divided by 3, it's going to be a 7. And then we need to combine it with 1, 3, negative 3, and 2. So when we add them, we're going to get 0 plus 1, which is 1, then 0, then 1, and then 9. And this basically completes our Gauss Jordan elimination. This is going to be complete. So my first row now becomes 1, 0, 1, and 9. Before I write everything else, what did we do to get those numbers right here? We multiplied the second row by negative 3, and then we added it back to the first row. Right? And then I'm going to copy down everything else. 0, 1, negative 4/3, negative 7/3, and 0, 0, 0, and 0. Now, as you can see, now we got the 1, the 0, the 0, and the 1. And the process is complete. That is the Gauss Jordan elimination. Okay. So, what do we need to do to finish this? We just need to rewrite the two equations that we have there. We're going to rewrite them. So I'm going to bring my first equation, which in this case it is read as 1x plus no y, so plus 1z. So I'm going to put plus z equals to 9. And my second equation says no x, then 1y minus 4/3 z, and that is equal to negative 7/3. So in order for me to write the solution, now the solution must be expressed as an order triple. But again, the solution must be expressed as 3 equations that will generate all the solutions. Now let me just tell you one little thing that you need to know. Whenever you're writing an infinite solution system, I show you back in section 8.1 that you could either write the solution in terms of x or in terms of y. The most common way was in terms of x. Now when you have a solution with x, y, and z, the solution is usually going to be expressed in terms of z. Meaning that the z is going to be the only variable that is going to be used to express my 3 solutions, to generate the 3 solutions. Now the last variable, it is already a z, so we don't need an equation for that, so that one is just z. We just need to find an equation for x and an equation for y. That's what we need to find out. So how do we find those equations? Well, to find the equation for x, we need to solve the first equation here for x. So I'm just going to move the z over to the other side. So that gives me x is equal to negative z plus 9. This is going to generate the values of x. Whenever z is equal to 0, you generate one solution. When z is equal to 1, when z is equal to 2, when z is equal to 3, and that will give me the values of x for any given value of z. Now, to find the value of y, all we gotta do, we need to solve for y on this middle equation. So we just need to add the 4/3 z to both sides, so we can leave the y by itself. So that gives me y equals to 4/3 z minus 7/3. That equation is going to generate all of the values of y. So when z is equal to 1, I get one solution. When z is equal to 2, I substitute the z with the 2, I get a different solution. When z is equal to 3, I get another solution. When z is equal to 4, I get another solution. It doesn't matter what z is equal to. Any solution that I generate for any given value of z, when replaced into all 3 equations here, all of them are going to be, it's going to be a solution to all 3, for sure. And this is how we solve a system of linear equations with Gauss Jordan elimination when the system has infinitely many solutions. Okay, so we have one last case of how do we solve a system of linear equations. With Gauss Jordan elimination, one last case, and that is the following. When you have a system of linear equations containing more variables than equations. This is a little statement, a fact that you all need to know when you're solving systems. It tells you the following. Whenever you have a system of linear equations that contains more variables than equations, the system has infinitely many solutions. Anytime you have more variables than equations, your system has infinitely many solutions. So, that goes back to the next and last problem. We're going to have a system with only 2 equations. Let's do that one, yeah. We have a system with only 2 equations, but what you can see is that this system has 3 variables. So there's more variables than equations. So this automatically tells you that the system has infinitely many solutions. Okay, that's what we're going to say here. This has infinitely many solutions. So once again, we need to work out the system using Gauss Jordan elimination. But keep in mind that at the end, your solution is going to be written in terms of z, again, because it's going to be infinite. So we need to write equations that will generate every solution of the system. So we have 8, 1, -1, and 8 for the first row, and 9, 9, -8, and 9 for the second row. Okay. Alright, so the first step in the process is that we need to make that 8 a 1. There is no switching possible because that 9 is not a 1. So the only solution that we have for this is that in order for me to make that a 1, I need to multiply this by the reciprocal of 8, which is 1/8, which is the same thing as dividing row 1 by 8. Okay, so I'm going to put right here the row operations on the side. So we're going to take the first row, which is 8, 1, -1, and 8, and all we got to do is divide everything by 8. That's going to give me a 1, that's going to give me a 1/8, that's going to give me a -1/8, and that's going to give me also a 1. So we're going to copy those values in my new matrix. So my first row is going to become a 1, 1/8, -1/8, and 1. And I'm just going to bring down the other values, which is 9, 9, -8, and 9. So, after making the top number a 1, the second step in the process is that we need to make the ones below zeros. But there's only one of them, right? So to make the 9 a 0, we need to use the process of addition by adding it to the equation that we made into a 1. So we're going to add the first and the second equation. 1, 1/8, -1/8, and 1. It's going to be added to 9, 9, -8, and 9. But before we can add them, remember that I need to multiply the opposite of 9 I need to multiply the 1 by the opposite of 9, which is -9. So -9 times 1 gives me -9. -9 times 1/8 is -9/8. Then -9 times -1/8 is positive 9/8. And -9 times 1, it's a -9. Then what we need to do is, we need to add it to this equation, which is 9, 9, -8, and 9. So when we add them, we're going to get a 0. And on the last one is also a 0. Now, right here, -9/8 plus 9. 9 is the same thing. 9 times 8 is 72. So 9 is the same thing as 72/8. Okay. So if I have 72/8 minus 9/8, it's going to be 63/8. That's what we're going to get. So 72/8. Okay. 72/8 minus 9/8, it's going to be 63/8. Now, this one is the same thing. 8 times 8 is 64, so this is -64/8. That's what -8 equals to in 8. -64/8 plus 9/8, -55/8. Okay. So that gives us the second row. So we're going to write this in my second row right here. So my first row, we're going to bring it down. 1, 1/8, -1/8, and 1. My second row becomes 0, 63/8, -55/8, and 0. So what is the operations that we use to make that 9 into a 0? We first multiply the first equation by -9, which is row 1 times -9, and then we added it to the second equation, which is row 2. Next, we already made the top a 1, we made the bottom one a 0. Step number 3, we need to make the 63/8 into a 1. And in order for me to make that 63/8 into a 1, we need to divide it by itself, but that would not be a good thing because it is a fraction. I would say on this one I will use a multiplication. Multiply by the reciprocal. The reciprocal of 63/8 is 8/63. So if I multiply that row 2 by 8/63, that's going to make it into a 1. Okay. So I'm going to take the whole row. 0, 63/8, -55/8, and 0. I am going to multiply by 8/63. So 8/63 times 0, that's going to still give me a 0. Now take a look at the following. 8/63 times 63/8, that's going to give you a 1. Now 8/63 times negative 55/8, the 8 and the 8 just cancels. They don't cancel, they reduce, they simplify. So that just leaves you with negative 55/63. And 8/63 times 0, it is just going to be a 0. So we're going to write those values in the bottom row. So this is what we're going to get next. 0, 1, negative 55/63, and 0. And I'm just going to rewrite the top row, which is 1, 1/8, negative 1/8, and 1. And so far, look at what we have on the system. We made the top number a 1. We made the bottom one 0. We made the bottom one a 1 right here. Now we have one more step to do, and that is make the 1/8 above that 1 into a 0. That's the last thing we would need to do. Make the 1/8 into a 0. How do we make it into a 0? By adding it to the equation that has the 1, which is to the second equation. So we're going to have 1, 1/8, negative 1/8, and 1. We're going to add it to 0, 1, negative 55/63, and 0. So we're going to add them together. Before I can add them, since I want to make the 1/8 into a 0, I need to multiply the bottom, the 1 by the opposite, which is negative 1/8. So negative 1/8 times 0, it's going to be 0. Negative 1/8 times 1, it's negative 1/8. Now the next one. When you multiply negative 1/8 times negative 55/63, I'm just going to do that one in the calculator right now. So negative 1/8 times negative 55/63, that gives you this. Make it a fraction by pressing math, enter, enter, 55/504. So it's going to be positive 55/504. And then negative 1/8 times 0, it's going to be 0. Then I need to add it to this equation, which is 1, 1/8, negative 1/8, and 1. So what's going to happen if I add them? We're going to get 0 plus 1, which is 1. Negative 1/8 plus 1/8 is 0. Now let's add those two fractions. 55/504, we're going to subtract 1/8 from it. And make sure you make it a fraction. Math, enter, enter. That's negative 1/63. Negative 1/63. 0 plus 1 is going to be a 1. So we are going to rewrite that into the top row. So my top row is going to become a 1, 0, negative 1/63, 1, and then I'm just going to bring the bottom row, which is 0, 1, negative 55/63, and 0. What is the operation that I used to change these numbers in the first row into this? Well, I multiply the bottom row by negative 1/8, so row 2 by negative 1/8, and then I added it to row 1. That's exactly what we did, and that's how we got these numbers. Now, as you can see, we got the 1, 1, 0, 0 in the second row. In the matrix. So this is my Gauss Jordan elimination. So the Gauss Jordan process is complete. Now, what we have to do to complete the solution is we need to write the system of the solution in terms of z, meaning that first we need the two equations right here. The first equation is 1x plus no y minus 1/63z, and that is equal to 1. Second equation says no x plus 1y minus 55/63z, and that is equal to 0. So we need to write the solution in terms of z. Remember, it has to be in terms of z. When you have a system with infinite solutions with x, y, and z, the solution must be expressed in terms of z. meaning that all my equations are going to contain the variable z. So the last one is already z, so we can just write z for the last one. Now, to get my equation for x in terms of z, all I have to do is solve for x in my first equation by adding the 163z to both sides. So it's going to give us x is equal to 163z plus 1. So that is how we're going to get my x, 163z plus 1. Now, what is my solution for y? Well, we need to solve for y in this equation. So we're going to add the 5563z to both sides of the equation, 55 over 63z. So it's going to give me y equals to 55 over 63z plus 0. It is just going to be 55 over 63z. And this is how we're going to generate the values of y. So let me explain to you again how this works. For example, when z is equal to 0, if you substitute the 0, you're going to get one solution. This something, comma, something, comma, something else, 0. When z is equals to 1, if you replace the 1, you're going to get a different solution. When z is equals to 2, you'll get another solution. When z is equal to 3, and so on, and so forth, and so forth. So that it will generate all the solutions for this system of equations for any given value of z, and any of those solutions, when substituted back into either one of these two equations, is going to be a true solution. Okay. So this basically completes the section 9.2. There's only one more thing that I forgot to mention in 9.1 that I will do in 9.2. Basically, how you solve a system of linear equations using the graphing calculator. Let me go ahead and solve one of the previous ones that we did. So, for example, this one that we did with infinitely many solutions. How do we solve it into the graphing calculator? It is very simple to do. You have to go in the calculator. First, you're going to go to the matrix screen by pressing second matrix. Once again, second matrix. Then you're going to go to edit on the right side, and you're going to press enter on edit. Now on that matrix, I'm going to put the number, the first number represents how many rows the matrix has. The second number represents how many columns the matrix has. In this case, this matrix has 3 rows and it has 4 columns. So we're going to make it a 3 by 4. And then you're going to put the values, which is 3, 12, negative 13. Then we have a negative 1. And after that, you're going to go to the second row, which is 2, 9, negative 10, negative 3. And then we're going to go to the third row, which is 1, 3, negative 3, and 2. After putting all the values into your matrix, what you have to do next is you're going to press second and quit. Quit is right next to the second key to go to the main screen. Now you're going to go to second matrix again. Now, in order for you to solve the system with Gauss Jordan Elimination in the calculator, you're going to go to the math column now. After you edited your matrix in edit, now you're going to go to the math, and you're going to go all the way down until you get to the RREF. Now, that RREF stands for Reduced Row Echelon Form. Basically, that's something I mentioned in 9.1. The process of Gaussian elimination or Gauss Jordan elimination basically consisted of reducing the rows to ones and zeros. So this is another name for that process. This is basically, interpreting the Gauss Jordan elimination, but in a different name. Reducing the rows. That's what the RR means. Okay. So we're going to press enter only one time on the RREF there. But then you're going to go to second matrix again, and you're going to press enter on the matrix A that we edited. And then close the parentheses, and that gives you the solution. Now, what happens if I get decimals? Then don't worry about that. You can make them back into fractions by pressing the keys math and press enter 2 times on frac, on number 1. And that gives it to you in fraction form. So you see, right here there should be an equal sign after between the negative 4/3 and the negative 7/3, between the 1 and the 9, between the 0 and the 0. There should be an equal sign, a vertical bar, but we don't see it here. Okay, but if you see, let's go back to the last equation that we got. It should be exactly the same thing that we got on my last set of equations. 1, 0, 1, 9, 0, 1, negative 4/3, negative 7/3, and 0, 0, 0, and 0, which is the exact same thing. Then all we have to do for the 0, 0, 0, 0, remember that means that the system has infinitely many solutions. So right there we have to express the solution in terms of z by solving the first equation for x, solving the second equation for y, and the z is just going to be z. And that's how we would end it after this part right here. Okay. So this explanation basically finalizes the section 9.2.